This is actually performing primarily on prosections. You'll be looking at the joints of the upper limb, and we're going to start first with the shoulder joint. There are two joints up here in the shoulder region. One is the joint between the humerus and the scapula, known as the glenohumeral joint, and the other one is the joint between the clavicle and the acromion of the scapula, known as the acromioclavicular joint. The acromioclavicular joint is a joint that is extremely movable without the associated extracapsular ligaments. The first ligaments that you will see in the acromioclavicular joint are between the clavicle and the acromion process, known as the acromioclavicular ligaments. Those form the capsule around the joint, and you can see this joint here as I move the clavicle back and forth. That's the position of the acromioclavicular joint. Now, the capsule of this joint is fairly weak and is strengthened primarily by some very strong ligaments that go between the coracoid process and the clavicle, known as the coracoclavicular ligaments. There are two parts to these, and you can see them both right here. These are very strong ligaments and give the major amount of the stability to the acromioclavicular joint. That's pretty much all you need to do with the acromioclavicular joint. The next thing we're going to do is move on to the glenohumeral joint. The glenohumeral joint is stabilized by a number of ligaments. First of all, the capsule of the glenohumeral joint is formed by the glenohumeral ligaments, and you will see that in most of the prosections the capsule has been opened up to expose the underlying head of the humerus. In this case, the glenohumeral capsule has been opened, and you can see it's cut right here, and I can stick my probe down inside the joint space where the head of the humerus articulates with the glenoid fossa of the scapula. The tendon of the long head of the biceps passes right through the joint space on its way to the supraglenoid tubercle of the scapula. A couple of other ligaments that are associated with the shoulder joint would be the coracoacromial ligament, which forms this nice shelf here, which gives some strength to the glenohumeral joint so that the head of the humerus can't be moved superiorly. It hits the coracoacromial ligament, and that stabilizes the joint superiorly. We're looking now at the anterior surface of the shoulder joint, and what I'm going to do next is to flip this joint over and look inside from the more posterior superior aspect. So as we tip the joint over and open it up to look inside, we're ultimately going to see the glenoid fossa. And we can see here the glenoid fossa where the head of the humerus articulates with the scapula, and then there's a dark ring around the glenoid fossa known as the glenoid labrum. This is a cartilaginous ring that helps to broaden that joint slightly and gives it a little bit more stability. That pretty much wraps up the shoulder joint and all that we need to look at. The next thing we're going to do is move down to the elbow and look at the ligaments that are associated with the elbow. Now we've moved down to the elbow joint, and we're going to look at a few of the ligaments that stabilize the elbow joint. First of all, the elbow joint is a simple hinge joint that takes place between the ulna and the trochlea of the humerus, and you can see that the ulna right here articulating with the trochlea of the humerus, and this is where the hinge action takes place. There's a second joint here that takes place between the head of the radius and the ulna, and this joint allows pronation and supination, and you can always tell the head of the radius because you can see it rolling inside. It's a ligament that holds it in place. The radius articulates with the humerus at a point on the humerus known as the capitulum right here. There are three ligaments that we have to look at that stabilize this joint, a lateral ligament and a medial ligament. On the lateral side is the radiocollateral ligament seen here, holding the head of the radius up to the humerus on the lateral surface. This ligament prevents adduction at the elbow joint. On the medial side, there's a similar ligament known as the ulnar collateral or medial collateral ligament, and you can see that ligament right here, a much broader ligament holding the ulna to the humerus, and this ligament prevents abduction at the elbow joint. A third ligament can be seen when we flip these muscle bellies out of the way. You can see that there is a ligament that holds the head of the radius against the ulna. And this ligament wraps all the way around the head of the radius and is known as the annular ligament and holds the head of the radius in place against the ulna. You can see that when I move the radius inside, that pronation and supination takes place within the annular ligament. Now we're going to look at a ligament that holds the radius and the ulna together in place in the forearm. We're now looking at the dorsal surface of the forearm. You can see the thumb side over here. And we've got the ulna and the radius. This ligament is known as the interosseous membrane, running between these two bones, and you should note the direction of the fibers of the interosseous membrane. They're running from the ulna distally to the radius more proximally in this direction. Now, when you look at this dissection, try and see how this direction of fibers can prevent the radius from being forced up into the capitulum of the humerus during load bearing at the wrist joint. So this particular ligament helps maintain the position of the radius relative to the capitulum of the humerus. Now we're looking at the wrist joint from its dorsal aspect, and again, for orientation purposes, the radius is right here and the ulna here. The wrist joint is actually two joints, and it takes place between the radial carpal joint, seen right here. And the radial carpal joint consists of the distal end of the radius and the scaphoid and lunate bones. The second part of the wrist joint is between the two rows of carpals, the so-called intercarpal joint, taking place between the capitate and hamate and the scaphoid and lunate. And you can see that joint space right here. Both of these joints allow flexion and extension, as well as adduction and abduction. There's not a whole lot to see related to these joints, except that the space between the radius and the ulna has a slight disc in it. So there's a disc that curves around between the radius and the ulna right here. And that disc also folds up over the distal end of the ulna and takes up some of the space between the ulna and the lunate bone. So this isn't truly a part of the wrist joint, but is protected by a cartilaginous disc.